question number 12. Question is this: two particles A and B initially at rest move towards each other by mutual force of attraction. At the instant when the speed of A is 2 meter per second and the speed of B is 4 meter per second, the speed of the center of mass of the system as that instant is. The first is the option A, 6 meter per second. Second is the 2 meter per second. Third option your 3 meter per second, and the fourth option your 0. See, meaning of this, let these are the two particles. It is given these two are initially at rest. Initially at rest. Now, due to the mutual gravitational force of attraction, as we know, gravitational force is equal and opposite. Whatever force on the M1 applied by the M2, same force on M2 applied by the M1. So, if we will see both two as a part of our system, if this is our system, so net force on a system is your 0. If net force on a system is 0, so if initially both are at rest, the center of mass velocity is 0, so finally the center of mass velocity also 0. So we can write here, since net force on a, since F net on a system is 0 and initial velocity of center of mass of system is 0 and initial velocity of center of mass was 0. So, its velocity remain, its center of mass velocity remain 0. So, correct option your option number 4. Hence, answer 4 is the our correct option. Now, question number 13. All the particles of a body are situated at a distance r from the origin. The center of mass, distance of the center of mass of the body from the origin may be. First option equal to r. Second option less than or equal to r. Third option greater than r. And fourth option greater than or equal to r. So, main point here, center of mass. Center of mass of a body always depends on the distribution of mass, and it cannot be beyond the largest or beyond the distance in which the largest particle having the longest distance. Let this is our system, and in this system one particle is here, and from fixed point O, one particle is here M1, one particle here M2, another your M3, another your M4, like this. So, whatever the masses of these particles, so if these particles are at the different distance, so as the distance of the particles are increases from point to center of mass, distance will be your increases. But the particle which is the largest distance from the point O, the center of mass cannot be more than the largest distance of that particle. So, RCM is always less than or equal to the position of particle which is farthest distance from a fixed point, which is farthest distance from a fixed point. So, position of particle, RCM always will be your less than. So, according to question, all particle maximum distance your R, so RCM is always your less than or equal to R. So, our correct option your option number 2 is the correct option. Question number 14. Question is given as, if a uniform hemispherical bowl of the radius of curvature R is inverted, the center of mass shift in y direction by a distance, first option R by 2, second option R by 4, third option R by 8 and fourth option 0. It means a question is given like this. You let hemispherical bowl is kept. This is your hemispherical bowl. Initially let hemispherical bowl kept like this and this have radius your R. Now, if the same bowl is kept inverted in this manner, and now they are asking what is the position shift in the center of mass. So, first we would like to find the position of center of mass of the hemisphere. See, hemisphere can be, hemispherical bowl is given, it can be taken as a number of rings like this. See, in this hemisphere we can have, let a ring, this type of ring we can make, which makes angle theta. This is your d theta, R is the radius. So, y coordinate of this, YCM is equal to your dm into y by total mass. So, how much the value of dm? Total mass your m and the area of the hemispherical bowl is your 2 pi r square. The sigma can be written as m by 2 pi r square. So, dm 1 by m, dm is your, see, this is the radius r and this thickness will be r d theta. So, mass, it means sigma, mass per unit area, area of that 2 pi small r, and small r is nothing, this is your capital R, r cos theta, 2 pi r cos theta. This is the circumference of that ring into r d theta, r d theta, this is the dm, and y means center of mass of this ring, that distance. So, this is nothing, r sin theta, and limit of theta here 0 to pi by 2. Now, simplify, 2 pi r, r square, r cube, the sigma into 2 pi r cube by m sin theta cos theta, or we can write sin 2 theta by 2 into d theta, 0 to pi by 2. So, see here, sigma into 2 pi r square, sigma into 2 pi r square is your m. So, this will be your r by 2 sin 2 theta d theta. Now, sin 2 theta integration minus cos 2 theta by 2 minus r by 4 cos 2 theta, and limit is your 0 to pi by 2. So cos pi minus 1, cos 0 this minus 1, so minus minus become minus 2. So this become your r by 2. So what we found here, the center of mass of the hemispherical bowl is your r by 2. So since this total is your r, so this is also your r by 2, so this is also your r by 2. It means there is no change in the position of center of mass. So there is no change in the position of center of mass. So our correct option here, option number 4. Answer 4 is the correct option. Question number 15. In this question it is given a uniform solid circular cone of base radius r is joined to a uniform solid hemisphere of radius r of the same density so as to have a common base. The center of mass of the composite solid lies on the same common base. Then the height of the cone is. First option here 1.5 r, second option root 3 r, third option 3 r, and the fourth option 2 root 3 r. So what is the meaning of this problem here? See, this is a cone and here one hemisphere. This is a common base and this have radius r. They are saying the center of mass of both lie at the common base or common surface here. Then what is the height of the cone? So height of the cone they are asking, and it is given this having same mass per unit volume. See, first we will calculate the center of mass of the hemisphere, solid hemisphere, and center of mass of the cone. Then only we can determine the exact height of this. The first calculation of center of mass of solid cone. So let this is the cone, and now we can solve like this. Cone of radius r. This can be said as a variable radius. So let here at y distance, this here let dy, and this is the let radius here x, and total height is given here h. So first I would like to calculate the center of mass of this. So first of all YCM dm into y by total mass. So dm is your mass of this, means mass per unit volume this, and area of that pi x square into dy into y by rho into volume mass 1 by 3 pi r square into h. Now from this rho and rho cancel, pi and pi cancel, 3 rho into pi cancel, 3 r square h x square y dy. Now from this triangle, let this angle your theta. So tan theta your x by this, x by h minus y as well as r by h. So h minus y is equal to your h by r into x. So value of x we can put then. See. So ycm is equal to your 3 by r square h, x square is equal to your r by h whole square into h minus y square into y dy, and limit is 0 to h. Now we can simplify. See, 3 r square cancel, h cube, expand this one, h square y plus y cube minus 2hy square into 0 to h. YCM 3 by h cube. Now simplify this. H cube we can take common. This will be your 1 plus this will be your h to the power 4 we can take common, y square by 2. So y square by 2 means 1 by 2, y to the power 4 by 4, 1 by 4 minus 2 y cube by 3. So finally, when we are simplifying this, take LCM here 12. 3h 2 6 plus 3 minus 8. So this is your 1 by 12 h by 4. The YCM is coming here h by 4. It means center of mass of a solid cone is at height h by 4 from the base. Similarly, we will find center of mass of the hemisphere. This is the one part. Second part, calculation of center of mass of solid hemisphere. See how to calculate. Let this your solid hemisphere of radius r. Same method again. Let this angle theta, d theta, and we can have this type of disc. Now again YCM. YCM is same formula we can use, dm into y by m. Now dm. dm is your rho. This radius is your r. This is capital R. This is your r cos theta. 2 pi r cos theta or pi r cos theta whole square into r d theta. Pi r cos theta is the radius. Next is the center of mass position. This is your r. This will be your r sin theta divided by total mass rho 2 by 3 pi r cube. Now check it. From here r square r to the power 4. So rho and rho cancel. 3 by 2 pi into r. Then we can integrate cos square theta sin theta d theta, and limit of integration 0 to pi by 2. Pi square r to the power 4th pi r will be there. Now integrate this one. Consider cos theta as t. Let cos theta as t minus sin theta d theta your dt. The same expression. The YCM is your 3 pi r by 2 cos theta as t, the t square, sin theta d theta will be minus t, the minus t square dt, and when cos theta your pi by 2, the t is your 0, so 1 to 0. So now the limit is your t cube by 3. T cube by 3, it means 1 by 3, so 1 by 3 and 1 by 3 will cancel here. So YCM will be your pi r by 2. So this is the new center of mass here, the whole system here. See, next point here. After knowing the center of mass of the this one, now since whole center of mass will lie on this, we can calculate. See, now for system m1 y1 must be equal to your this your y1, this here y2, and this have mass m1 must be equal to your m2 y2. Now the mass of this rho 1 by 3 pi r square into h y1, center of mass of that your height your h by 4 is equal to m2, mass of this rho 2 by 3 pi r cube into y2, y2 your pi r by 2. Now we can simplify. After simplifying, you will get the result here, and that is equal to your root 3 by r. Check it. Rho and rho cancel. Now then further we can write h square is your 4 pi r. So h square is equal to your 4 pi r square. So h will be 2 root pi into r. So our correct option is your option number 2. So answer is your option number 2 is the correct option. Now question number 16. In the question number 16, if the mass of a body is uniformly distributed throughout the body, then its first option, center of gravity coincide with its center of mass. Second option, center of gravity coincide with its centroid. Third option, center of mass coincide with its centroid. And the fourth option, center of gravity, its center of mass and its centroid will all on the same point here. So whenever mass of the body is uniformly distributed throughout the body, then it's, see, first thing of center of mass and center of gravity. The center of mass is a point which depends on the mass distribution of the body. The center of mass is a point at which or about which mass is uniformly distributed. But if we are talking about the center of gravity is a point where whole weight of the body is your about to concentrate or is acting. The center of gravity depends on the value of g also. So it is, even mass is uniformly distributed, But if the center of gravity is changing, or if the center of gravity is not uniform, then the centroid or center of mass as the center of gravity point will not coincide. The center of gravity coincide with the center of mass only when the g value are uniform, but center of mass will be always at the centroid of the body. So option number 3 is the correct answer. To answer your 3 is the correct option. In question number 17, two blocks of masses 10 kg and 30 kg are placed along a vertical line. The first block is raised through a height 7 centimeter, and the distance by which the second block should be moved to raise the center of mass by 1 centimeter. The first option here 1 centimeter up, second option 1 centimeter down, third option 2 centimeter down, and the fourth option 2 centimeter up. See, let this your vertical line, and it is given two blocks 10 and 30 kg are placed along the vertical line. See, let this your 10 kg block and another your 30 kg. It can be taken as M1, it can be said as a M2. Somewhere center of mass will be there. So, change in the position of center of mass is your M1 delta Y1 plus M2 delta Y2 by M1 plus M2. Now, they are saying center of mass of the system you move by 1 centimeter. It means it move by 1 centimeter. So, upward we are considering positive and downward we are negative. So, this is your plus 1. M1 your 10, and it has been given first block is moved by 7 centimeter your upward. So, 10 into 7 plus M2 your 30 kg, and delta Y2 we have to find, and M1 plus M2 your 10 plus 30 and 40. From here we can say 40 is your 70 plus 30 delta Y2. So, delta Y2 is your minus 1 centimeter. The minus 1 indicate your downside. So, 30 kg block should move 1 centimeter down. So, correct answer your option number 2. So, answer 2 is the correct option. The question number 18, a uniform rod of mass M, length L is hinged at one point of its end A, as shown in the figure. A force F is applied at a point at a distance x from the end A. The acceleration of center of mass of the rod varies with x as. There are 4 options in the graph is given. In the first graph, a straight line not pass parallel to the x-axis. In the second option, it is also a straight line passing through the origin, and third curve passing through origin, and fourth here again straight line. So, now see the solution of this. So, it is given a rod, and this rod is hinged at point A, and length of the rod is given your L, and the force F is acting at distance x. See, then they are asking how the acceleration of the center of mass of the body is changing. Since the rod is your hinge about end A, so the center of mass have acceleration here, that is your nothing tangential acceleration. So, that depends on the torque about point A. So, see, torque is equal to your I into alpha. So, torque is equal to F into x, Moment of inertia of the rod about this ml square by 3 into alpha. So, alpha is your 3f by ml square into x. So, ACM, A tangential you can say, the A tangential your L by 2 into alpha, L by 2 and alpha value 3f by ml square into x. From here LL cancel, the A tangential is equal to 3fx by 2ml. So, from here it is clear A tangential is proportional to your x. So, our graph will be your, if we are looking the x versus AT graph, it will be your straight line like this. So, our correct option your option number 2. Answer 2 is the correct option. Question number 19. The question is this: a uniform rod of length 2L is bent in the shape of English letter L as shown. The coordinates of its center of mass are: first option 2L by 3, L by 3, second option L by 8 and L by 8, third option L by 4 and 3L by 4, and the fourth option your L by 3 and L by 6. See the solution here. A rod has shape L shape. It is given like this. This type of shape is given, and this is taken as a y axis. This is your x axis. So, this part of the rod has center of mass somewhere here at coordinate 0, L by 2. This part has center of mass somewhere here. So, this is your L by 2 and this is your L. The coordinate of this your L by 2 and L. Mass of this your m, this will be also m. So, see, if we are looking here XCM for this m1 means m into 0 plus m into L by 2, total mass your 2m. So, this is your L by 4. YCM m into L by 2 plus m into L by total mass 2m. So, this will be your 3L by 4. So, our coordinate here L by 4 and 3L by 4. So, correct option your option number 3. So, answer is your option number 3 is the correct option. Question number 20. Question is that in a boat of mass 4m and length L on a frictionless water surface, two men A and B, A having mass m, B of mass 2m are standing on its opposite ends. Now, the man A travels a distance L by 4 relative to the boat towards the center, and the man B moves distance 3L by 4 relative to the boat and meet at the point to the man A. The displacement of the boat on the water till the man A and B meet will be: first option 5L by 28, second option 0, third option 3L by 4, and the fourth option 23L by 2. See here. As per the question here, this is let boat of length L and mass 4m. Length L, mass 4m. There are two persons, one having mass m, another having mass 2m, standing at the opposite ends. A person A travel distance L by 4. See, let for example, this is the initial position here. So, when both of them are meeting, so this is your man A and man B. The man A and man B both are here. A and B. A has travelled L by 4. B have travelled 3 by 4. And let the displacement of both your x. As we know, there is a no change in the center of mass position of the system, because external force on the system is your 0. See, change in the center of mass of a system is written as m1 delta x1, m2 delta x2, m3 delta x3 by total mass m, but it is 0. m1 we can say mass of your boat mass 4m, and displacement of the boat your x, the center of mass, that side we can say let your positive from this, and this side we can say your negative. So, change in the center of mass of this 4m into x plus m2 let this person, this man, earlier it was here, now it is here, the position change in center of mass L by 4 plus x, mass of this your m L by 4 plus x, plus another man mass 2m, change in position of center of mass. Now earlier he was here, now he is here. So that distance here, earlier the distance from this your x L, now L by 4 plus x. So change is here L plus x minus 3L by 4. Man B, initial position of the center of mass was your L. Now the position of center of mass of B is your L by 4 plus x. The final minus initial, final L by 4 plus x, final L by 4 plus x minus initial your L. Now it is 0. To simplify, 4x plus L by 4 plus x plus L by 4 minus L, the minus 3L by 4, 2x minus 3L by 4, 3L by 2. Now that we can simplify, 4x plus x plus 2x, 7x, and this is your 3L by 2 can be written as 6L by 4 minus L by 4, the minus 5L by 4. So x is equal to your 5L by 28. The shift in the center of mass of the boat is your 5L by 28. So correct option your option number 1. Option number 1 is the correct answer. Question number 21. A paraboloid shaped uniform solid object is formed by rotating a parabola about the y-axis as shown. If the height of the body is your h, the position of its center of mass from the origin. The first option your h by 3, the second option your h by 4, and the third option your 2h by 3, and the fourth option your 2h by 4. Now see the solution. It is given that the body is your parabolic like this. So first of all, if we are looking the equation of this, So from that we can say y is equal to your some constant k x square. This is our equation of this parabola. Now this height is your maximum height, this your given your h. And when y is your h, this we can get some value. Then how to calculate? See, I am considering a disk here at y distance and this here dy. So center of mass of that, so y cm dm into y into dm. dm rho is the rho per unit volume, and this that y, this your x. So pi x square into dy. The pi x square will be your area, dy your thickness, into y, center of mass, rho pi x square dy. Now limit of y 0 to h, 0 to h. So y cm, rho into pi cancel, x square we can write y by k, so y square dy 0 to h, then x square is your y by k, so y dy 0 to h. Now simplify, this will be your h cube by 3, this is your h square by 2. So finally we are getting 2h by 3. So y cm is your 2h by 3. So this is our option. The correct option, your answer number 3 is the correct option.